There are more examples of revolutionary discoveries from corners of biology than this central part of biology. If you take discoveries that have won the awards, those discoveries didn't happen at one moment. The dawning that it was important over a larger time frame took 20 years when other people started to sort of gravitate to those ideas. And so in that sense, you can't feel responsible for that sort of a revolution, even if you were the spark that started it, because the revolution came to you. But again, when you discover something like that, you don't know it's right at that moment, right? You say, well, maybe it's wrong, we don't know it's the right gene, might be the gene next door. And so you sort of get excited, but not too excited. But then, you know, a week later, we knew that it was, and that we could get excited about it, but then it wasn't new. It was a week old. That's a concern much of the time when you do biology. Am I studying something general or some weird peculiarity of some weird creature? And over time, our sophistication as biologists increased to realize that no, we're studying something that's an experimentally accessible window. What we're studying is related to what's in butterflies and what's related to what's in squirrels and what's in us, it turns out. I was not working on it for working on aging. I was working on it for understanding how an animal takes signals from its environment. Our lab discovered that the first sort of dramatic discovery we made in the aging pathway was that the mutation that's in the genes that leads to the longest increase in lifespan of a worm were in the insulin-like receptor of the worm. The finding that these single gene mutations that Cynthia Kenyon found and that Michael Klass found, that they can have a dramatic effect, one mutation, was the first hint that there's a program here, that this is not just an accumulation of garbage. And then as it all congealed on the insulin pathway, it said, well, here's the actual program. The program is insulin signaling. And what the output of that program is, that's the hormone. What the hormone is regulating to actually sort of control what it is that happens during aging. That's the new mystery. That's what we need to figure out. What we're finding is that some of these aging pathways are about how organisms deal with toxins in their environment. We're now exploring how poisons are detected in animals. I'm very enthralled by it.